Humans live at the center of a black hole. Why didn't we die? Imagine that the Earth has shrunk to a single diameter, 1.7 centimeter sphere. So, the Earth will become the most mysterious object in the universe. One black hole. Think about whether it's physics or astronomy. You can't even imagine the boundaries of the universe. Even less likely to touch the edge of the universe. This and the speed of light cannot be escaped. Black holes are similar. A black hole is a cosmic abyss, a trap known for its attractive force. Once you are absorbed by his attractive force, can never escape. But where do black holes lead? This is one of the ultimate questions in astronomy. Answer the question may reveal the greatest secrets of the universe. Black holes could really be the gateway, a portal to another universe. What is gravity to truly understand the black hole? We need to change the way you think about gravity. At school, we were taught that gravity is a force between two objects, invisible attraction. For example, the moon orbits the Earth because the Earth pulls the moon with its gravity. This is Isaac Newton in the 17th century, how the concept of gravity was first introduced. But physicists have been around for more than a century. You don't see gravity that way anymore. Newton's concept of gravity, it has long been recognized by Albert Einstein's theory, in particular, his general theory of relativity. Einstein's revolutionary ideas. According to Einstein, gravity is not a pressure at all. Instead, he's the result of bending space. To understand this, imagine that. Tighten the sheets on your bed. Pull tightly on the four corners. Then put a heavy ball in the center. Represent the Earth. The sheets will sink and dent in the middle. Then you can get on the edge of the depression. Roll a tennis ball. In other words, you let the tennis ball go around. Emphasis ball run. Here's the thing, there's no tension involved. Heavy balls don't attract tennis balls. Instead, tennis balls are just drawn along by the presence of heavy balls. The sheets are bent. Path of action. From the outside, this looks like the pull of gravity. But it's not. It's an illusion. The heavier an object is, the concave he made in the sheets of space, the deeper the sink. Physicists call these depressions gravity wells. When the largest star dies, their cores collapsed, creating a gravity well so deep. To climb out requires you to travel faster than the speed of light. As far as we know, this is impossible. It is these inescapable gravitational levels, more commonly referred to as black holes. Another way to think about black holes is they warp space to such an extreme extent, so that all the exits actually bend back. It's a maze. All the seeming ways out, it will only make you fall deeper into it. But where does the cosmic labyrinth lead? The first to solve Einstein, the equations of general relativity. It was German physicist Karl Schwarzschild. And here's what's even more impressive. He was in the First World War, during the German army, completed the job while serving. However, Einstein's equation has two possible outcomes. The time in each solution moves in the opposite direction. Okay, which one should I choose? The physicists of nature chose that. Gravity looks like us, the solution to the attraction of habit. After all, gravity seems to be pulling things in. He won't push them away. But some physicists question, why do we abandon another level so quickly? Does the exact opposite of black holes exist? Imagine that. Watch a movie about a black hole eating a cosmic feast. But put it backwards. It is not something that is inhaled and can never escape. It's thrown up and never returned. In this vast cosmic labyrinth, all paths lead to the outside, rather than internal. Such a time-reversed black hole. It's called the white hole. Astronomers have never seen a white hole. There is also no evidence that they're not just mathematical illusions, a mathematical glitch in the matrix. Just because of love, Stan's equations allow them to exist, doesn't mean they really exist. White holes are hard to spot because from a distance, and they look like black holes. They might even have rings of matter. This disk around the black hole is a sequence of substances waiting to be consumed, but it's equally possible it's the disk of material that's being spewed out by the white hole, unless you get close enough, actually seeing matter appear or disappear. Otherwise, it's hard to tell the difference. However, the biggest problem with white holes is that they seem to violate against one of the most sacred rules of physics, the second law of thermodynamics. He said the universe should have moved on with time, become more chaotic and disordered. We are a prime example of this rule. Our bodies, wrinkles and aging over time. Black holes follow the same rules. They make the universe more chaotic because they relentlessly tear apart stars. But what about the white hole? The mystery of white holes rewind the video of black holes. Suddenly, the chaos is miraculously sorted out. Scattered pieces clump together. The entire star is ejected. The universe suddenly became cleaner. The white hole will be the center of the universe. Benjamin Button's cosmic equivalent, reverse aging. This is also the case for most physicists and astronomers. Don't think of white holes, the main reason why it exists in our universe. White holes may still exist in another universe, a time in the opposite direction towards a running universe. But here's the thing. Einstein's equations allow black holes and white holes connect. Enter a black hole in our universe. You might come from a white hole in another universe, spitting out black holes and wormholes. The official connection between black holes and white holes, called Einstein-Rosen bridge, however. These tunnels are better known as wormholes. The name of the wormhole comes from the sitting apple, worm at the top. The choice we face? If the bug wants to reach the bottom of the apple, it has two options. It can crawl around the outside, or it can chew through a tunnel in the middle. Such a shortcut will be a literal wormhole. There are several kinds of wormholes in astronomy. Among them, Einstein-Rosen bridge was the first to be discussed. But before you start fantasizing about using wormholes, before disappearing into another universe, the wormhole itself is also problematic if an example can pass it. Then a wormhole is said to be traversable, except for Einstein's general theory of relativity, prohibit the existence of traversable wormholes. According to the calculations of Einstein and Rosen, wormholes are very unstable, so that it collapses before anything has a chance to get through. But that didn't stop it. Other physicists seek ways to support wormholes. An idea is the use of strange-sounding foreign substances. This substance strangely has negative energy. We don't even know if this substance exists. It sounds like white holes and wormholes might be hopeless, but there are some glimmers of hope. Einstein's general theory of relativity. It's not the only theory. Quantum mechanics is another big monster in physics. He deals with the universe in subunit grains, rules on subscales. The two theories are inconsistent. Physicists hope to merge them into one single theory, a theory that could explain the entire universe, from the smallest subatomic particles to the largest galaxies. Although not yet found, but such a theory is called a theory of everything, or quantum attractive force theory. One of the most promising candidates, known as the ring quantum attractive force. According to Einstein's general theory of relativity, the fabric of the space is perfectly smooth. Loop quantum attractive force does not think so. Imagine that. Magnifying space with the most powerful microscope in the universe. According to the ring quantum attractive force, we will see, like your previous sheets, space is it's a series of little stitches. These tiny stitches is the ring attached to the theory's name. We're talking about very small. In a cubic centimeter of space, there would be something bigger than a cube in the entire observable universe. cm more true and false. A staggering 10 trillion, trillions of trillions, 10 to the 99th power. That's one, followed by 99 zeros. A separate stitch is the smallest possible structure in the universe. According to the ring quantum attractive force, each pin has a certain storage capacity. Imagine a sponge. He can only absorb so much water. Once the sponge is fully saturated, any extra water will bounce off. The same is true for rings of space. When matter falls into a black hole, more and more matter is stuffed into a ring. But like a sponge, the ring will eventually become saturated. Anything else that falls in will bounce off and head in the opposite direction, like a caterpillar turning into a butterfly. The black hole has become a white hole. By this means, the white hole becomes a return, an important prediction of quantum attractive force. If this theory is proven to be correct, white holes may even help explain the birth of the universe. White holes and the Big Bang. Most astronomers agree that the universe, 13.8 billion years ago, in an event known as the Big Bang, flash out. Energy and matter from a very small point. Outburst. Could that be a white hole? A previous universe may have collapsed. Fall on yourself. Until a ring reaches its limit, it rebounds outward again. This is the physics behind the quantum attractive force, the situation raised by the family, if they are right. So white holes are not just some fresh, known as cosmic curiosity. They are our universe, an important connection with their ancestors. One might eventually explain why we. Here are the links between these issues. Welcome to the channel to open their minds. Leave a message for formal listening.